Hello. Hey everyone. Can someone confirm if you can hear me and everything is good? We can start with a bit of our introductions. Uh, my name is Gundeep Arora. I am a senior applied scientist in the central machine learning team at Amazon. Uh, I have been with Amazon for over three and a half years, and have been in and around machine learning for the last eight and a half years. Uh, I have I primarily work on models that are related to India's consumer business, and try to find ways to reduce losses that can happen because of any reason, because of any network issues or anything, and that can happen in Amazon's India retail business. And prior to this, I worked with companies like Flipkart, Microsoft, over the past multiple years, right? So that's from my side. Who would you like to go next?
Thanks, Gandhi. So my name is Vu Nguyen. I am from Amazon, Australia. So I have been working on the machine learning for around 10 years now. And before joining Amazon 3 years ago, I work mostly on Bayesian optimization, one of the active research topic for optimizing the experiment. And at Amazon, one of my current project is to doing the price optimization. So given a product, we want to suggest what is the best price to help the customer and also to gain profit for Amazon. So that is a little bit about myself.
Right. Thanks, Wu. Who would you like to get started with some of the questions? There's one question which is around practical applications on Bayesian estimation that are currently used in the industry. Uh, you'd like to start? I think you're working on one right now, right? Or you've been around that one, and then I can also talk about one sometime back.
Sure. Yeah, so I have been working on a Bayesian method in industry, and in particular, because using the Bayesian formalism, we can incorporate the prior knowledge into our model. And typically, that prior knowledge we can get it from the domain expert, and with the domain knowledge, we can improve the model. And by doing that, the Bayesian method will be more favorable than the non-Bayesian setting. So that is my short answer. And if you ask me about a couple of examples, so we can have the price optimization in Amazon. We use the Bayesian formalism. And even in other retail and marketing optimization, we also have that Bayesian estimation in practice.
Right. Right, that's quite interesting. So, what I can also chime in and talk about how I had applied Bayesian. I didn't apply it here within Amazon, but in one of my past stints, one thing that wanted us was we had like a host of classification models back then. We did not have GPTs of the world where we could have a single language model that could do all kinds of classification, or a single foundation model that could do all kinds of classification. So what we had built, we had a host of classification models, and what we wanted to do was that we wanted to estimate. However, we made the model, we wanted to estimate our understanding of precision and recall of that model in production in different scopes. Classifier and which score bucket needed more attention, and where we were not very confident. So the way we did was we evaluated posterior over our for the precision as a random variable. We evaluated posterior over each one of them, and tried to come up with a greedy algorithm that could perform that could do optimization across different models and choose which is the right one to do, right one to pick up by just using how the variance of the posterior over the precision. So higher the variance over the precision of the posterior, we understood that we do not have a very strong understanding of that precision metric in that particular score bucket for that classifier, and hence we would sample more from those domains from that region and get them annotated. So the idea was kind of like Bayesian active learning is also quite related here. So yeah, that's one way I had applied Bayesian estimation sometime back. Right. Then there's a question on books and courses to follow. Do you have any suggestions on top of your head right away?
Yes, so I mean, because I learned about the topic around 8 or 10 years ago, so at that time, we follow one of the book from Dave Collar, who is the professor from Stanford. She famous for her online course on probabilistic graphical model. And after that, I'm not sure about other, more modern techniques, but I pretty sure that if you go to Google, you can find a couple of suggestions for this book.
Right. I think the course is on Coursera. There's also a version of it on YouTube, if what I last recall. I mean, when I was going through a similar phase, that again is 5 to 6 years back. So yeah, very similar time frame. Let's take another example. There are quite some questions on the Hamiltonian HMC. I think you're referring to the Hamiltonian Markov chain, right? Question, right? Explain the use of HMC in recommender systems. Right.
I can briefly answer that question. Yeah, I mean, just
sure,
briefly.
Please go ahead.
Yeah, right. So HMC or Hamiltonian Monte Carlo is one of the popular methods for learning the graphical model. And if we take the recommendation system and formulate the problem as the graphical model, then we can use one of these methods for estimation, such as Monte Carlo, variational inference, or Hamiltonian Monte Carlo. So basically, it is not special for recommendation system, but it can be used widely for all of the graphical model.
Right. But would you like to give an example of what posterior distribution would you be interested in, for which you would not have a closed form or an analytical solution, where you would go with something like an HMC?
Right, a good question. So I think from the retail perspective, let's say we have a lot of customer and a lot of product, and we want to learn the customer preference in buying some of the product, and because we don't know about that preference, we're gonna formulate it as some variable. So let's say X will be the observed customer, and Y will be the hidden preference. So we try to estimate the distribution of that preference. So that is the posterior distribution of Y given X. And we also have some of the historical data on the transaction from Amazon website. And then after that formulation, we can use HMC to learn the distribution of Y given X and etc.
Right. I quite agree to this. Yeah. So the point that you made, right, of using user or item as a at the end of the day, we have to recommend items to certain users, right? And we can formulate either of these problems as a posterior estimation of these problems, right? So that is one where you could use it, right? What are the current research topics in probabilistic graphical models? I think Bayesian optimization is like an evergreen topic where how could you optimize, how could you leverage Bayesian optimization, hyperparameter for optimizing hyperparameters of different kinds, right? Not everyone has the budget to run and train large models. How can you arrive at the right model with the right parameters at the fastest? So that is one very, very basic example that I can come up with, right? Further, I see examples of PGMs in in across domains. I've been working on graph neural networks, and even there, I see probabilistic graphical models and their combination with graph neural networks coming in every now and then. From an applied perspective, the not directly related, but in some places, retail also requires you to do explore exploit, and that is where that is where models like Thompson sampling and so on also creep in, which are not very directly related to probabilistic graphical models, but they definitely leverage topics that are discussed within BGMs. Wu, any thoughts from your side on this?
Right. So additional to some of the research topic you mentioned, I think other researcher they may thinking about some of the advanced optimization method to learn the complicated graphical model where we have large number of variable. So the interaction between these variable may be complicated to learn by using the basic method. And also, they try to develop some estimation method that can leverage GPU computation. So they want to estimate the computation should be as efficient as possible.
Right, right. Well, I don't know. I moved something and I'm not able to see my question panel. Can you take the next
Sure.
set of questions while I figure out what is wrong with my system?
Okay, sure. So the next
Now
question.
it's all.
Yeah. The next question
Okay,
is
let me take it.
Okay. Yeah.
Go ahead.
The next question is, can you explain more about Hamiltonian Markov algorithm? I guess that is Hamiltonian Monte Carlo, not Markov. So I think because I'm not working on the HackMC, so I'm not sure if we can easily answer that question. But I know that HackMC will be more advanced method compared to the classical Monte Carlo. And the way HMC do estimation is by sampling. And HMC rely on some of the principle in the dynamic of the physical system. I think they define something about the velocity and all the momentum from this sample. And based on that momentum, they adjust the direction and how far they want to move from the existing samples. That is from the top of my head. Other than that, I don't know much about the MC, unfortunately.
I'll just add some more points here. So you can think of Hamiltonian Markov. First of all, you need to be very clear of what is MCMC, right? What is Monte Carlo Markov chain? The idea is that you build a Markov chain, and then you take, and what is Monte Carlo? Monte Carlo is primarily about sampling, as you mentioned, right? So the idea is that you have a posterior distribution and you want to take samples out of that posterior distribution. You want to have that distribution in the form of samples. Now, for that posterior distribution in the form of samples, or any distribution in the form of samples, you build a Markov chain, and on that Markov chain you traverse from one step to the another, and how you traverse is, and then you take samples, and there is like an acceptability or a denial criteria for every algorithm. So if you understand this MCMC concept with some clarity, now you can think of every different algorithm in some way or the other trying to prove how you traverse through the Markov chain and how do you accept or deny samples to add and take and remove, right? So that is the crux, right? In Hamiltonian, so the idea is that you try to build, as you mentioned, it's based on the physical nature. So you have there is a dynamical system within which you have a Hamiltonian path, and it's like it's like a like Hamiltonian path is like it's a path in a graph where you visit each vertex exactly once, right? So and then you on that path there are some endpoints which are adjacent, and then the resulting cycle is like the Hamiltonian cycle. But there are all these details. The primary crux being that this is based on a physical system, and I see a lot of questions coming around Hamiltonian dynamics. Is there a specific part or aspect of it that was not clear, or that is something troubling? MGMC is a costly process. because you have to do a lot of rejection while doing every kind of sampling, and it is more often than not when you deploy MCMC, at least what I have seen in my experience, is that you try and create a Gibbs sampling approach. The point of Gibbs sampling is that the sampling in Gibbs, I'm not sure if it was covered in this lectures, but the Gibbs sampling setup is leverages conjugacy, conditional conjugacy, and helps you, ensure that sampling part and all those parts, there is some optimal, there is some speed gain while in the sampling step, right? Yeah, I see a lot of questions. Is there anything specific that you would like us to cover? Within HMC is a question. I'm looking for the bottom questions that we're looking for.
Yeah, for me, I try to go through some of the question, and if I can answer in the text, I can just reply directly in the text.
Sure.
Yeah. And I think you can move to some of the general questions. So, for example, how much math is enough to get started at the applied scientist internship or full time at Amazon? Some of the very general questions.
Yeah, you'd like to take it, or you want me to go take a stab at this?
You can go ahead with that question, and then I will go through the rest of the question.
Okay. Yeah. So for mathematics at Amazon as an applied scientist, I think what is I'm a little old school when it comes to this. I would always prefer understanding things in good depth, appreciating, and then building on top of it. The reason why and for this I would always recommend understanding linear algebra very well. For linear algebra, I would always suggest taking Professor Gilbert Strang's course that is freely available on YouTube. So many versions of it. Then probabilistic understanding of the notion of probability, and calculus to a certain extent. I understand that there are a lot of models these days that do not require you to have extreme depth in terms of mathematics. But what I can still see is that any process, any method that you are trying to apply and deploy in a system that is going to have an impact on humans will require to understand what are the risks involved in it, right? Even if you see today, even if you take an example of something like a chat GPT or anything of those kinds, there is a considerable amount of thought that is given into the risk that a system like that can obey. And the theory that I'm aware of some part of theory that is used in ChatGPT is also around fairness in algorithms, and that requires an extreme understanding of linear algebra, probability models, and so on and so forth. So having your ground covered in probability and linear algebra is kind of extremely important, and all these fundamental topics that we are covering as a part of the summer school, you may see that they may not every algorithm, not every aspect may be applied there, but a general understanding of what a probabilistic model is and how the latest models are incorporating those principles will give you a more crisp and a clear understanding of how these systems actually, or how these ideas actually end up getting deployed, and they impact human lives. Yeah, that's a fairly long one from my side. How would you like to take it?
Yeah, I think that's a great answer. I can move to the next question. So, can you suggest efficient algorithm in low-end devices for face recognition? So I can suggest two algorithms. The first algorithm is on the principal component analysis, where we can try to do the dimensionality reduction from the original images to the lower dimensional representation. And from that lower dimensional representation, we can perform face recognition from the low-end devices. That's in the first approach. The second approach is try to use the cloud computing platform. So suppose that if you have Wi-Fi connection, you can make a query to the cloud, and we can, from the cloud, it will have a better computing facility that can quickly estimate the result and send back the result to our device. And from that, we send to the customer. And
There's one question I think you missed, which was around when it comes to accuracy and other metrics, according to your experience, what is the comparison of ANNs with PGMs, competition, performance, and trade-off? I don't see them as two different model classes. PGM or probabilistic models or Bayesian models is a thought process, and now with the advancement in neural networks as well, we have moved forward with neural network models that can act as probabilistic models as well. If you would like to understand something like variational auto encoders, which are on the self-supervised side, or if you would like to understand on normalizing flows, which are applicable both in self-supervised and in supervised settings, you can integrate and leverage the benefits of probabilistic models within neural networks. So there is not like a versus B. It is like it's like an ecosystem, and understanding the components where each component can go and be a part benefit from the other will help you understand what has to be applied. And at the end of the day, it's more important about understanding what the problem that you are working on needs. I'll give you one very small instance where I have been working on an instance where we have realized that and we have a paper which is under submission right now, which discusses how doing probability distribution estimation on top of regular binary classification setting can help you increase your precision and recall at the high end, right? For a lot of business use cases, we have to deal with very high precision, right? And how can you improve your recall for the same precision, right? By having a probability distribution rather than a single point estimate of that, right? And while this is known, while the method of arriving at that probability distribution was same, nobody was looking at its benefit in improving precision and recall. And that is something that we picked up and did a small setting proof of it as well, to show that there is actually benefit in understanding the entire distribution, right? So there is no one answer where I will give you that one is better than the other. It's very problem specific, and sometimes it is based on the result that you have to take a call which one is a better decision to go ahead with. Are you worried about latency? Are you worried about performance? Is it fine if it takes a second extra but you get a better performance, and that better performance delights the customer and the entire experience? So that is how we work backwards and take a decision, right? So that's an answer from my side.
Thanks for the answer. I think I have another compliment answer to this question. So for the artificial neural network, typically we formulate it at the supervised learning problem. We have the input X and we have the output Y, which can be the classes for the MNIST images, or it can be a single node for a regression problem. And deep learning can easily solve that particular problem. However, for probabilistic graphical model, it will be used for a more generic problem where you may have a collection of observed variable and then a lot of collection of unobserved variable. And in that complicated situation, artificial neural network may be not applicable, not straightforwardly applicable. So in that particular application, we need to use the probabilistic graphical model to solve that problem. So that question actually related to if you compare what is the best between train and airplane. So airplane will be used for something, but train will be useful for another purpose.
That is true. That is true. Right. And there is another similar question. I am jumbling a few questions. I know there are some questions in between that we'll come back to. But on this same trail, there is like, can you provide example of real world application with probabilistic machine learning models Excel? I think one aspect that I am aware of is that you have to understand that our models may not see the entire distribution of training data. To give you a very basic example, a machine learning model that trains, we've seen this example recently, and I saw it on a video somewhere where there was a Tesla self-driving car, Tesla, which was driving, and it did not have an understanding of what a cart is, what a horse cart or a bullock cart or whatever that is, right? And there are, because it is trained that on a data that is coming from a certain environment, right? And a lot of extreme cases in which Tesla has to be prepared is that what if there's a sudden occurrence of an animal, or something falls from the top, or something or the other, right? Not all of those extreme instances can be covered by purely training data, right? And that is where I have seen applications on zero shot learning and few shot learning, where people have used probabilistic graphical models to formulate a probability distribution on your data samples coming from different classes, and then using those distributions, they draw samples out of those distributions, and then they try to train a model out of it. The idea here is that you understand a distribution on top of your input data set, or a transformed version of your input data set, and that distribution helps you improve your modeling output. Right? I can also point to some works which are in zero shot learning, and these methods apply to images, all kinds of modalities. Modality of data is not so much of a concern. With the improvement in artificial neural networks and deep learning, and combined them with probabilistic ideas, you can now train everything end to end. That worrying about, oh, this will work only on tabular data, or this will not work on images, is not so much of a concern. However, it is possible that certain class of models may do better on certain class of modalities, so you have to be careful with that. Yeah.
Right. And I think I also answer a couple of questions in the chat box. So, for example, what can you explain? What is the inference in Bayesian network? So my answer is that when performing inference in Bayesian network, we are given a observed node or observed variable, and we want to infer about the unobserved node. And in the previous example where I link to the application in Amazon, observed variable is something that we see, like we see the customer property, but we don't know the customer preference. The customer preference will be the unobserved variable that we are trying to estimate in the Bayesian network. So the next question is different between Bayesian network and Markov random field. So the short answer is that Bayesian network is a directed graph, whereas Markov random field is a non-directed graph.
Right. So in Markov random field, there's a transition probability matrix that you kind of formulate, and then you can move in either direction. So that's the right perfect way of saying. And I'll just add one more point on that question on inference. I think this is something that I found it difficult when I was initially learning on this. That what is this meaning of inference? You were always told training, testing, forward pass, backward pass, so on and so forth. That's what we hear, right? Or matrix multiplication. Inference is the easiest, or the most basic way I can define inference. It is not complete, but it will give you a hang of it. Is that inference refers to the idea of testing in a Bayesian setting, or in a probabilistic setting, right? You observe some input, and you want to predict, or you want to arrive at a distribution on what you want to predict, or what you want to do, right? So previously, regular models, you would just do single input, single output. Here you would have a distribution, at least in the Bayesian system setting, you would do that, right? Let's go ahead. What other questions we have?
I think there is a follow-up question to your answer previously about the artificial neural network and probabilistic graphical model. You talked about a paper in which your team was able to minimize the type 1 and type 2 error simultaneously by formulating a probability distribution. Do you have an open source GitHub repo for the code, or is it Amazon proprietary?
Oh no, we just made the submission. In fact, yesterday was the deadline. So we will be releasing the code very soon. Yeah, and I think the paper would also be on open review in a couple of months. So you will be able to see that. Yeah. We haven't released the code yet. We have to go through certain checks to ensure that there is a certain code quality, since it goes with an Amazon hallmark. So we will do that. So that's still under covers right now. Yeah.
I'm pretty sure that is the iClear submission. So all the best for that.
Right. Thank you. Yeah. What else? Is
I think
there
the next question,
any other?
yeah, the next question would be: can you please guide where we can get hand-on practice on this probabilistic graphical model? Hand-on practice.
Right.
Very good question, right?
It's a very
So
good
I mean,
question.
there is no clear answer for this question. But for me, if I just started my career in machine learning and I want to learn that probabilistic graphical model, I will look at some of the GitHub repository with Google Colab, where people have a whole notebook with the nice visualization and explanation. I will start downloading the data, run step by step, and print every variable to see what it is. And if I have any question, I will look at the textbook or I will ask my friend for explanation. But
Right.
different people
Right.
may have different, may have different approaches.
Right. Or maybe how about doing this? How about coming up with a paper? These days there are extremely good GitHub libraries, GitHub repos that accumulate a lot of recent works that are done on probabilistic models, right? And then you can also head on to there is this papers with code, right? So you can get the code there, use something like Colab or some other computing method, or run it on your computer as well, and try and understand what that paper is doing. What is it talking about? What part, like let's say you understand about MCMC, or you want to see how they're using MCMC, what is the problem they're trying to solve, and then trying to think about, okay, where else would you face a problem like this in your real life, and how else could you apply how could you apply this solution to a problem that you're trying to solve in real life. You have to understand that a lot of applied machine learning is about solving problems of humans that are being faced in real life, right? So that is where I would always recommend to just go ahead and try to see what research work is happening, and that will bring you build in habit of reading papers, understanding code of how people write code, and trying to do a problem, or even just change the data set and see how well that new problem does for your data set, or a data set that you have been working on, or are aware of some other examples in other domain, right? That can help you build more proficiency in writing code, in understanding papers, and then in the process also learning through this, right? So that's one another way you could do with PGMs, or any topic, to be honest. Yeah.
The next question will be: can we use these for images? So I think that yes, the short answer will be definitely yes. Probabilistic graphical model has been famous for the images problem. For example, when we do image segmentation or for semantic understanding. So given an original image, we want to understand what is this image about. So if that image is about football, so we want to see the player, we want to see the audience, we want to see the stadium, the grass, the goalkeeper, everything. So we the observed variable will be the pixel. Pixel will be in the color pixel, red, green, blue in 3 channel, and the hidden node or hidden variable will be what it is about the goalkeeper, about the player, about the stadium. So we have that. If we formulate that image semantic understanding problem at the probabilistic graphical model, we can do posterior inference to learn the semantic meaning. So that is one of the application I can think of.
Right. Right.
The next question is how HMC changes the path when it see that path may lead to its start points. But I don't think I can answer that question because I'm not familiar with HMC.
I can make a attempt. I think it's a function of the dynamics, right? And the dynamics are dependent on both the potential and the kinetic energy. Like as you mentioned, right? HMC comes with is kind of borrowed, is how I can say, from the idea of physics, and you have notions of energy and dynamics that come into play, right? And the idea is that Hamiltonian dynamics, like the way HMC algorithm kind of simulates the dynamics. It has to adjust the path or the trajectory based on the energy footprint or the way kinetic and the potential energy interplay around that region, right? So when it sees so when you have like for example, how would you say, right? So when you have like high potential energy, which is kind of high potential energy is kind of low probability, because you have to understand it in a very physical and a natural way, that there is a notion of trajectory, and at high potential regions you have low kinetic energy, and hence you have lower uh, chances of moving forward or backward, right? If you just think in English terms and not so much in physics or even scientific terms, right? Like just think in those terms, you will get a sense of what they're trying to talk about, right? And the idea is that the idea is that the it avoids those regions of high potential energy, and tries to leverage the regions of high kinetic energy, right? So, and the way it also does is that you don't always have to sample the same point, right? Like you sample every point. You can neglect there are those burnout samples that is common across in all burn-in samples, which is common in MCMC, where you can drop a lot of samples and then go ahead and pick up another sample. The idea is that you want highly uncorrelated samples which are far off from each other in the trajectory. Yeah, I hope that answered. If you have anything follow, please feel free uh, to ask something more. Yeah.
Another question, I think I answered in the chat box. That is, could you please provide a brief list of these key mathematical concepts to learn machine learning, so that I can review and reinforce my understanding as needed during the program? So I think in my experience, I often learn and look at some of the concept about in linear algebra, statistics, and probability. And in particular, for linear algebra, we use a lot in optimization or even in dimensionality reduction. So we need to understand the vector spy, the span column, and then the Asian vector, and how to do the Asian decomposition. And after doing that kind of Asian decomposition, we understand how BCI work, and especially it's related to one of the question about how to do the face recognition using BCI. For statistics and probability, we can look at the Bayesian formalism, Bayesian concept. What is the discrete distribution? What is the continuous distribution? What is the PDF, probability density function? And what is the CDF, cumulative discriminative function? And other related concept as well. Maybe Gundeep can complement me with other suggestion.
Yeah, so I think broadly you covered it right? And it is not that the day you study linear algebra you will be able to master machine learning. I think it's a build up. Machine learning has been around us for, I think the most that I know is that regression algorithms started when Alan Turing was around, right? So, and since then there have been SVM came probably around 60s and 70s, and then there have been neural networks have been around 80s, right? So the traces of modern day deep learning go back really long, right? I remember early 1990s when folks like Jan LeCun were trying to solve MNIST character recognition problem, and they gave the ideas of CNN. So the point is that that I'm trying to make here is that it's a evolution that has happened over multiple years, and that will require you to have strong foundations in linear algebra, probability models, and I think there are also topics. I remember seeing a playlist on YouTube which is around maths for machine learning. If you just search for mathematics for machine learning, there are courses which just focus mathematics with the idea with also referring to where which algorithms in machine learning will this kind of mathematics be useful for. So that also becomes very important. And the way machine learning is evolving every day, I think it is going to the understanding of mathematics, right, is only going to change and like improve with time. I'd always suggest that having strong fundamentals is important, and then slowly building on top of them day over day, you will be able to understand, right? And you have to keep a balance of continue to read new papers, try and understand. You may not understand a lot of research, but when you try and delve into it even a little bit, you will be able to identify what aspects of mathematics that you are not totally aware of, and then you can go back, fix it, come back, go over it again. It's a very iterative process, like any machine learning model. Our learning process is very similar to how most machine learning models also learn, right? If you want a good model, we our brain should also be a good model in those lines, right?
Yep. So I think we reached to the last question in the list. But in the next 5 minutes, we can talk a little bit about Amazon. So I can start first. So you may know that Amazon is one of the leading company for e-commerce, and Amazon is known for its unique culture that we try to focus on the customer. So we are expected to prioritize customer need and work to provide the best solution for the customer, and we try our best to achieve the highest standard as possible. Um, and at Amazon, we are encouraged to make innovation, to explore new ideas. At the same time, we also got opportunity to do the continual learning to learn more about our machine learning foundation, as well as learning a new problem. And so at Amazon, every year we have the always have the internship opportunity open as on level. And in Australia team, so I think we have 9 position opening for 2024, but most of the position is for the applied scientist intern who are expected to be the current PhD student.
Right. Right. I think I can also add a little bit about the culture. I think Boo just captured it rightly. Amazon aims to be the most customer-centric company, and it's one of those leading tech firms. With all of that, I think there is an additional responsibility that us as employees of Amazon and in applied science, the way things have been moving all across the industry, to be at the forefront, right? And understand how we can leverage different improvements in technology, push it further so as to make a better impact for our customers. The idea is that if technology is married rightly with the customer needs, that is where we see true value creation and true benefit for everyone, right? It becomes like a win-win situation. The customer gets a delight, they benefit from Amazon, and then Amazon benefits from them. So that is how. That's a very simple and a very basic way of putting things. That we everything that we do and think of is with a focus of improving our customers' experience and understanding what our customer needs, going back, listening to our customers, refining what they listen, and then try and innovate using the technology that we have, or build technology that is necessary to solve that problem, right? And that technology is not just restricted to good front end and back end systems, but also to machine learning systems that can augment them and enhance the customer experience. So we always work from the idea of improving our customers' experience, and then bake in this point, right? Regarding the idea of applied science internship, I have myself mentored 4 interns in 3.5 years that I have been here at Amazon, and most of my work has been around ensuring that they understand the problem deeply, and they also go back with at least one good solution that they have implemented themselves, and they end up learning around how problem formulation, how problem thinking, how iterations, how machine learning development cycles work within Amazon, and how we think about proceeding towards any problem or trying to solve any problem while we are at Amazon. So that's how we think, and yeah. For the internship opportunities, I think the recruiters would be the best set of folks who would be able to give you good information, right? So yeah.
Yep. So I think we can take one more question from the console. So the question is there resources to understand complex mathematical equation in research paper? I have been reading some of the CVPR and IEEE transaction paper. The architecture of the model seems clear, but when I read the mathematical part, it's become confusing. So how do people, get an edge in reviewing these? So I would say that in my experience, it will take some time for us to build our background and get familiar with that topic. And I mean, we are not expected to understand everything from the paper, but we need to get the high level understanding on what they are trying to do, and then we can break the whole paper into multiple parts, and we try to focus in understanding each part separately. So that is, I think, the way I approach the paper.
Right. I think that's an interesting viewpoint, and I think the problem that you are facing, you're not the only one. All researchers, everyone who is even remotely new or they're very experienced as well, they take some time to get a whole grasp as to on the paper, on the equations in the paper. It takes time, it takes effort, it takes repeated effort, and at times it is possible that you, while reading a paper, you may not be aware of the details of it. Go online, search for it. Great articles on Medium and great blogs, great YouTube videos that capture these concepts in great detail. You just need to identify what concept is this most related to. How can I pick that concept quickly? Pick it up, come back, try again. If you're not able to do, try again, discuss it around. Sometimes there's a very trivial aspect that one may be missing, and discussing research papers is a very standard way of dealing with new ideas. Even at Amazon, we have interest circles within our team. We have interest circles and reading groups, even where everyone is invited, and so like interns also benefit by learning there, and they can always ask question as to, okay, I'm not able to understand this particular equation. How does this impact the entire model, or why is it important in obtaining the result that the model is obtaining? And we have a clear discussion on that, and that brings out new ideas and some new approaches. So yeah, just keep trying. So that's the holy grail, right? And someone when I looking for names, I think you can see the name for both of us in the chat box in our videos on the left side. Wu and Gundeep, we are two applied scientists at.
Yep.
Who is based out of Australia?
Yeah.
I am based out of. Yeah. Who are you in Melbourne?
No, I am located in Adelaide in South Australia.
Nice. And I'm located in Bangalore. Yeah.
Right. I went to Bangalore in June, 3 months ago.
Oh yeah. I think I was not in office, so we didn't get to meet. But yeah, right. Great. We have more questions. Who? Yeah, I think there are two more questions. Let's take them.
Yeah, so I think I briefly answered in the chat box, but basically they're asking what are the chances of getting the job in machine learning without PhD or master. So I think the position are opening for on level, but it's gonna depend on your prior experience. If you have a lot of experience, if you can do the work, then you can get the job. It doesn't matter much to get a degree.
I quite agree. In fact, just yesterday I was talking to someone who was an intern at Amazon, and he has done exceptionally good work with Google and other companies. Now that he's traveling, he was an intern here. He was just an undergraduate, and he was an intern, and he has in a span of 3 to 4 years just picked up. He's just, I think, 2-3 years out of Amazon, and out of his undergrad. He was here during his final year undergraduate internship for 6 6 months, and he has grown. I've seen him grow over the last some time, and he's done really good work. And the point is that. As people spend more time learning, keep improving their skills of maths, of understanding paper, continue to read more papers. They end up improving, and he's a very good scientist. He's a very solid scientist with very strong programming skills, and that gives him a very strong edge. So, as you mentioned, degrees are not all that important. They kind of give a signal or an indication that things may be in the right direction, but they are not the only reason that someone gets hired. I think the primary reason when I am interviewing, I look at how deeply they understand the problems and how well versed are they with aspects of theory, so that one day when if God forbid something goes off with a model, the person should have the understanding that they can go and fix the model to any degree of issue. And once you're able to understand, and that comes when you have a strong understanding on how the model is working, how it is trained, and everything around that, right? So, yeah.
Yep, absolutely. So I think we reached to the end of the section today. We can come back in another 8 minutes.
Yeah, I think we have another session lined up for 3 p.m. I think there are a couple of questions. We will take them at 3 p.m. And yeah, see you guys then.
Yeah, bye.
Bye.